There are two kinds of people in engineering. People who ask, does it work? And people who ask, but could it work better? The second type is more expensive. They take longer, they miss deadlines, they get their bosses fired, and every once in a while they build something so absurdly overthought, so magnificently excessive, that it changes the entire industry while simultaneously bankrupting the people who paid for it. These are the 10 most over-engineered cars ever made. Not just cars with a lot of features. Cars where the engineering itself became the point. Where the problem wasn't building a car, it was building a car that had no right to exist the way it did. Let's start somewhere unexpected. The Toyota Supra. Not for the reasons you think. Everyone talks about the 2JZ like it's a tuner punchline. But here's what actually happened. Toyota's engineers built a straight six that made 276 horsepower from the factory. Fine. But this engine could be pushed to 500 horsepower without touching the internals. No new pistons. No rebuilt head. You just added boost, and it held together like it had been expecting this the whole time. There is no other engine from that era with that tolerance for abuse. Toyota built so much structural margin into the 2JZ that owners became accidental performance engineers. They'd add a bigger turbo, expecting to blow it up, and it just asked for more. And if that wasn't enough, the Supra carried a 4-channel ABS system with individual sensors at each caliper that could read yaw and pitch in real time. F1-derived brakes. On a $33,000 Grand Tourer, nobody asked for them. Toyota built them anyway. Now let's go to Italy. The Lamborghini LM002, called the Rambo Lambo for reasons that become obvious the second you see it. In the early 1980s, Lamborghini built an off-road vehicle for a military contract that never materialized. When the military passed, instead of shelving the project, Lamborghini put a 5.2-liter V12 from the Countach into a 6,700-pound SUV and sold it to civilians. The engine had 6 Weber carburetors, each requiring special dust filters for off-road protection. The chassis was custom tubular steel. The brakes used twin calipers on each front disc because one wasn't enough. The tires were developed specifically for this car. Nothing in production could handle the combination of weight and V12 level speed. And when Lamborghini realized the engine got too hot during low-speed crawling, they didn't detune it. They added a separate cooling circuit that is not solving a problem, that is deciding the problem must accommodate the engine. Next, Cadillac Elant. This one is special because the over-engineering wasn't in the car, it was in how they built it. Cadillac partnered with Pininfarina in Turin to design and build the Elant. Fine, but instead of shipping the bodies by boat like every other manufacturer would, Cadillac chartered a fleet of specially modified Boeing 747s to fly them from Italy to Michigan. Weekly, every week, a 747 full of car bodies crossed the Atlantic. They called it the Air Bridge. The engineering required to modify those aircraft to carry cars was genuinely sophisticated. The added cost per vehicle was staggering, and the car that came out the other side had advanced but notoriously unreliable electronics, which meant the most impressive piece of engineering in the Alliance's existence was the supply chain, not the product. There's something poetic about that. The most over-engineered part of this car never touched the road. Here's where it gets genuinely excessive. The Mitsubishi 3000 GT VR4. In 1991, Mitsubishi's engineers made a list of every available performance technology and put all of it in one car. Active aerodynamics. 4-wheel steering. A twin turbocharged V6 with sequential boost. Full-time all-wheel drive with electronic torque distribution. An adaptive suspension that read road surfaces and adjusted damping in real time. All of it simultaneously in a 1991 production sports car. The weight penalty was enormous because the car was carrying an engineering department's entire wish list in its nose. Haggerty once described the VR4 as a fiendish exercise in excess. That's not a criticism. Mechanics who worked on these cars got very good very fast because they had no choice. The 3000 GT didn't reward curiosity. It demanded competence. Let's talk about a car that nearly broke the company that built it and became an icon for exactly that reason. The Mercedes-Benz W140 S-Class. Development started in 1981. The car launched in 1991, 10 years. In the process, Mercedes spent over $1 billion and the cost overruns were severe enough that the project's chief engineer was dismissed. That is not a footnote. That is what happens when engineers are told there are no budget constraints. What did they build? A car where the trunk lid closes itself if you don't push it hard enough. Double pane glass on every window to reduce wind noise. Electric windows that automatically reversed if they encountered an obstruction. Rear chrome antennas that physically deployed from the body panels to guide drivers when reversing, instead of cheaper parking sensors, because sensors hadn't been perfected yet and Mercedes refused to do things imperfectly. The heating system continued to blow warm air after the engine was switched off. BMW had introduced a V12 in 1986, and Mercedes couldn't tolerate that. So they delayed the W140's entire launch by 18 months to develop their own. They also secretly built 85 prototypes with a V16 because there was a rumor BMW was considering one, just in case. The W140 is what engineering pride looks like when it becomes competitive paranoia. It is the last car Mercedes built where accountants clearly lost every argument. What came after was a different company, more efficient, more rational, less interesting. Now for what might be the greatest engine ever put in a road car, wrapped in a story of corporate stubbornness that is almost too good to be true. The Lexus Elfa. Development started in 2000. The car launched in 2010. 10 years. In that time, Lexus built an aluminum chassis, tested it for years on the Nürburgring, decided it was too heavy, and scrapped it entirely. They switched to carbon fiber. Problem? The technology to weave complex three-dimensional carbon shapes at their required precision didn't exist. A supplier told them it would take 10 years to develop. Lexus did it in one. Toyota had started as a textile company. The loom, invented by its founder in 1906, funded the entire car division. A century later, Elfa engineers built a 3D circular carbon fiber loom with 144 bobbins that wove 12 layers of carbon fiber directly around a mold. No seams, no weak points. They invented the machine to build the car. And then there's the engine. The V10, built with Yamaha, including their musical instrument division, revved from idle to 9,000 RPM in 0.6 seconds. A standard analog tachometer physically could not track the engine speed. It moved too fast. Lexus had to develop a digital instrument because the needle couldn't keep up. The exhaust system was tuned using acoustic engineering, the same way Yamaha tunes brass instruments. Toyota lost money on every single one of the 500 units sold. Nobody cared. An Elfa that launched at $375,000 now sells for over $1 million at auction. The people who laughed in 2010 are standing in line today. Next is a car that rewrote the physics of what a road car could do, and the bill it ran up to prove it. The Bugatti Veyron. In 1997, Volkswagen chairman Ferdinand Piëch decreed that Bugatti would build a car with over 1,000 horsepower and a top speed above 400 kilometers per hour. His engineers told him it was impossible. He told them to make it possible. The engine they built was 2 V8s joined at the crankshaft. 8 liters. 4 turbochargers. And because all that combustion generates heat that would destroy normal materials, they added 10 radiators. 10 dedicated cooling circuits, engine coolant, oil, transmission, differential, intercoolers, each with its own radiator. The The three largest took 15 hours each to fabricate. A single oil change cost $21,000 and required 27 hours of labor. At full speed, the fuel tank emptied in 12 minutes. The tires were developed from scratch by Michelin over 5 years because nothing in production could survive 407 kilometers per hour. The speed key, a separate key inserted beside the driver's seat, signaled the car to drop its suspension 65 millimeters and reconfigure its aerodynamics for maximum velocity. The car literally changed its own shape when you decided to go fast. Volkswagen lost between $4 and $6 million on every Veyron sold. Total development costs exceeded $1 billion. They built 450 units. The Veyron was never a business. It was a statement. Let's talk about a car that replaced springs with philosophy. The Citroën SM. 1970, a French luxury car with a Maserati V6 and a high-drop pneumatic suspension so advanced it made everything else feel primitive. The system used pressurized hydraulic fluid instead of springs. It was self-leveling, so ride height stayed constant regardless of load. It was front-to-rear interconnected, so hitting a bump at the front reduced the impact at the rear. The car ironed out the road. The steering got heavier at speed rather than lighter, which was the opposite of every other power steering system. The brakes were inboard, at the differential, not the wheels, to reduce unsprung weight. The headlights turned with the steering in 1970. Citroën claimed the lowest drag coefficient of any production car of the era. This was a collaboration between French engineering philosophy and Italian engine charisma, producing something neither country could have made alone. The SM required specialized mechanics who understood both, which meant that outside France, it was effectively impossible to keep running. That was never a bug. The SM wasn't built for practicality. It was built to demonstrate what was possible when practicality isn't the constraint. Now an engine that became its own religion. The Mercedes-Benz W124 diesel. Between 1984 and 1995, Mercedes built the W124 to a specification, not a price. The engineers were told to build the most durable mid-sized car they could imagine, and the diesel variants running engines developed under Ferdinand Piëch were functionally indestructible. German taxi fleets ran W124 diesels past 1 million kilometers. Some kept going past 2 million. The engines were built with tolerances so precise that internal wear was almost negligible by standards other manufacturers considered impossible. Every component was specified to outlast the car's expected lifespan by a significant margin. Mercedes was building to a standard that made the cars expensive and impossible to justify on a spreadsheet. They did it anyway, because that was the brief. You can buy a W124 diesel today for less than the price of a used Honda Civic. With maintenance, it will run for another 250,000 miles. That is not nostalgia. That is the engineering talking. And then there's a car that took everything on this list and multiplied it by the most irrational number in automotive history. The Mercedes AMG 1. If the Veyron was Volkswagen proving a point, the AMG 1 is Mercedes proving they haven't run out of points to prove. This is a road car powered by an actual Formula One powertrain, not inspired by F1, not derived from F1. The actual powertrain from the actual championship-winning Mercedes F1 car, built at the same facility in Brixworth where they assembled the race units. A 1.6-liter hybrid V6. 4 electric motors. 2 drive the front axle. 1 sits on the turbocharger to eliminate lag by electrically spinning the turbines between combustion cycles. The MGU-H system, lifted wholesale from the race program. The engine must be rebuilt after a set number of hours, like an F1 unit. Making a racing powertrain behave like a road car required engineering solutions that didn't exist until Mercedes invented them. The car took years longer than announced. It cost more than projected. Owners waited. Nobody walked away. You don't walk away from something that exists because an engineering team decided the laws of thermodynamics were a suggestion. So here's what all 10 of these cars have in common. They were built by people who looked at the state of the art and found it insufficient. They were funded by organizations that briefly lost their minds in the best possible way. They were criticized as impractical, overpriced, and impossible to justify. And every single one of them changed what the industry believed was achievable. The 2JZ told the world that factory engines could have hidden potential no accountant had quantified. The LM Nero 2 told supercar makers they could go anywhere. The Elant proved the supply chain itself could be over-engineered. The 3000 GT V-Art 4 showed that putting everything in one car was a viable strategy. The W140 proved there was a line between engineering pride and ruin, and at crossing it produced the last great German car of the 20th century. The Lufa showed Toyota that losing money on 500 cars could be the most profitable thing a brand ever did. The Veyron proved 1,000 horsepower in a road car was not science fiction. The SM proved hydraulics could replace springs. The W124 proved the car could outlast the manufacturer's own expectations. And the AMG 1 proved that Formula One was never just for the racetrack. Engineering is expensive. Over-engineering is more expensive. But cars built without compromise are the ones still being talked about 30 years later. The spreadsheet never wins in the end. The obsessives do.